In this video, we will continue working through the review, starting with number 9. In your history course, you made an 82 on exam 1, where the scores had a mean of 85 and a standard deviation of 6. While in biology, you made a 56 on exam 1, where the scores had a mean of 60 and a standard deviation of 5. In which course did you do better relative to the other scores in the course? So since we want to know relative to other scores, we want to do a z-score. So let's look at the history. The history, you made a 82. The mean was an 85, and the standard deviation was a 6. So looking at this z-score, that's going to be 82 minus 85 divided by 6. When we calculate this, 82 minus 85 is 3 divided by 6 gives us a negative 0.5. Now, looking at biology, you made a 56, the mean was a 60, and the standard deviation was a 5. So for here, we have 56 minus 60 divided by 5. So 56 minus 60 is negative 4 divided by 5 gives a negative 0.8. So looking at these two scores, recall that the smaller the negative value, the better it is. And so actually you made better in history relative to other scores in the course. So again, you did better in history relative to the other scores in the course. Looking at number 10. The national average for mathematics SATs in 2011 was 514. Suppose that the distribution of scores was approximately bell-shaped with a standard deviation of 40. So we know that the mean is 514 and the standard deviation is 40. So actually, before I even read parts A or B, I'm going to go ahead and just basically create a number line. And I'm going to put the mean here in the center of 514. And then I'm going to go 3 spaces each direction. And I'm doing this because it says that it's approximately bell-shaped. And so I know that this is going to be the 68, 95, 99.7, or the empirical rule. And so what I'm going to do is I'm going to take 514 and I'm going to add its standard deviation of 40. And when I do that, I get 554. And then I'm going to add 40 again and get 594. Add 40 again and I get 634. On the other side, I'm going to take the 514 and I'm going to subtract the 40. I get 474. Subtract 40 again. I get 434. And subtract 40 again and I get 394. The reason I do this is because knowing that it is bell-shaped, that means that in between these two values is 68%. In between these values, it's going to be 95%. And here, it's going to be almost all, or 99.7%. So within what boundaries would you expect 68% of the scores to fall? Well, 68% of the scores will fall between 474 and 554. So you would expect 68% of the scores to fall between 474 and 554. What percentage of the scores would be above 594? So let's go back and look here. So here's 594, And I know that between these two values is 95%. I want to know about this values out here. So what we can do is we can take 100% minus 95, which will give us 5%. That's how much is outside of this circle right here. Well, but I have two tails, so I have to divide that by 2. So 5% divided by 2 gives 2.5%. So this area out here is approximately 2.5%. So approximately 2.5% of the scores would be above 594. Now I get to do this because recall that it said that it's approximately bell-shaped. When it states that it's approximately bell-shaped, then we can use the empirical rule. If it does not state that, then we have to go into Chebyshev's rule with the 1 minus 1 over k squared. But this is not that case, this is the empirical rule. So let's look at number 11. Okay, so give probabilities as decimals rounded to the nearest thousandth, 3 decimal places. Be sure to show all your work. Okay. So a day of the week is selected at random. Find the probability it is a weekend day. So we want the probability that it's a weekend. Well, if we think about a week, there are 7 days in the week, and there are 2 days on the weekend. So 2 divided by 7, rounded to 3 decimal places, is going to be 0.286. So the probability that the selected day is a weekend day is 0.286. Now we're going to be rolling a die. Recall that the possibilities for rolling a die are 1, 2, 3, 4, 5, and 6. Find the probability that we rolled a 4. There are 6 total possibilities, and one time is it a 4. So that's going to be 0.167 rounded properly. So the probability of rolling a 4 is 0.167. Find the probability of rolling a number less than 3. So we want the probability of less than 3. Well, here's 3, and we want less than. That's only going to include the 1 and the 2. We still have 6 possibilities, but the 1 and the 2, those are 2 possibles that we actually are going to find. 2 divided by 6 is going to be 0.333. So the probability of rolling a number less than 3 is 0.333. Let's look at the probability of rolling a number greater than 0. So we want the probability greater than 0. Well, look at you still have 6 possible outcomes. Let's look at those 6 possible outcomes. Well, all 6 of them are actually greater than 0. So that's going to be a 6 out of 6, which is a 1. So the probability of rolling a number greater than 0 is 1. So what's the probability of a number less than 4 or an odd number? So the probability less than 4 or odd number. Well, when we look at this and we look at our possibilities, less than 4 or odd numbers. Notice, if I do less than 4, that is going to be not the 4. Less than 4 is these values. Well, an odd number includes these values. Notice there's a couple of them that get counted twice. So where I'm solving this, I need to look at the probability of less than 4 plus, because I want an or, the probability of an odd, and then I have to subtract out their overlap, the probability that it's a number less than 4 and an odd number. Well, less than 4, that was 3 out of 6. An odd number, there were also 3 out of 6. But there were 2 of the numbers that were counted in both of my deals here. So I'm going to subtract out a 2 out of 6. 3 plus 3 is 6, minus 2 is 4. 4 out of 6 gives me a 0.667. So the probability of rolling a number less than 4 or an odd number is 0.667. That's looking at rolling a die. Now we want to look at drawing a card from a deck of cards. So you may want to have that sheet with the deck of cards in front of you. So we want to look at the probability of drawing a 9. There are 52 cards in a deck, and looking at it, there are 4 9s. The 9 of hearts, the 9 of diamonds, the 9 of clubs, and the 9 of spades. So 4 divided by 52 is going to be 0.077. So the probability of drawing a 9 is 0.077. The probability of drawing an ace and a black card. So this is probability of ace and a black card. Well, since these things happen at the same time, or could happen at the same time, basically what we're saying is the probability of drawing a black ace. And when we talk about black aces, there's the ace of spades and the ace of clubs, so that's only 2 out of 52, and we divide this out and we get 0.038. So the probability of drawing an ace and a black card at the same time is 0.038. Part C says we want to look at the probability of drawing a red card or a queen. Now, can my card be a red and a queen at the same time? Yes, because we have the queen of hearts and the queen of diamonds. We want an or, so we're going to look at the probability of the card being red plus the probability of it being a queen minus the probability of a red queen. Because these red queens have already been counted here, they also get counted here. So the probability of a red card is 26 out of 52, because there are 26 red cards. The probability of being a queen is 4 out of 52, and the probability of a red queen is 2 out of 52. So we add this up and divide by 52, and we get that the probability of drawing a red or a queen is 0.538 when rounded properly. Probability of not drawing a club. So we want the probability of not a club. That's going to be equal to 1 minus the probability of being a club, because we're looking at the opposite, the complement of it. And so we're going to take 1 minus, there are 13 clubs out of 52. And so when we take 1 minus 13 divided by 52, we end up with 0.75. So the probability of not drawing a club is 0.75. The probability of drawing a jack, given that it is red. So we have the probability of a jack, given that it is a red card. Recall that whenever we're talking about given, this means the probability of a jack and red, so in other words a red jack, divided by the probability of that given part, which is red. So how many red jacks are there? there are 2 out of 52 red jacks. How many red cards are there? There are 26 out of 52 red cards. So we're going to take 2 divided by 52, and then we're going to divide that by 26 out of 52, and we get 0.077. Now if you look at just a jack, that's going to be, or a red jack even, that's going to be 2 out of 52, which is our numerator. But because we know that the card that we drew is a jack, or I'm sorry, is a red card, that simplifies or reduces our denominator, meaning I only have 26 cards to select from, so 26 out of 52. So I want you to try some of these probabilities, and then let me know if you have questions.